Hey there everybody, welcome to the next video of the course. In this video we will be talking about random numbers in Python, how you generate them, and then some uses of them. So this video has two goals. First of all, show you how to get random numbers using Python, and then apply them by integrating them into previous topics like loops, if statements, and so on. So once you can generate random numbers, what can you do with them, especially given previous tools that we have? So let's start with just getting random numbers. First and foremost, at the top of your code, you need this command here, import random. What that does is that imports a library that's built to help generate random numbers for you. So essentially what's going on here is that generating random numbers, Python or not, is a very hard thing to do. It's a very complex task to generate truly random numbers. And it's actually far beyond the scope of this course to approach that problem. So somebody else, though, has basically solved that problem. I mean, not entirely, perhaps, but it's almost a matter of philosophy at some point. But anyway, that problem has basically been solved, and the solution is embedded inside this library that we are going to grab. So that's what we're doing. We're grabbing a library of work that other people have done so that we can just tell the code, hey, give me a random number between A and B, where A and B are numbers you've chosen. So if you want to choose a random number between, say, 5 and 30, whatever, you would write a command like this, random.randint, and you put a 5 there and a 30 there, and then I've stored that result inside of a variable I've called number. You, of course, don't have to call this thing over here number. You can call this X or random number or whatever. It's up to you. This command here doesn't change. Random dot, and then this is short here for random integer, and then put the two numbers you care about here. So for example, random.randint 1, 10 will choose a random number between 1 and 10. And it's important to note here that the English word between is kind of ambiguous, right? Like, do you mean strictly between, or can you be at the boundaries, you know? Can you be a 1 or a 10? And notice, you could be 1 or 10. So these parentheses here are actually inclusive on both left and right, which is different from like our string commands or our list commands from before, where if you wrote like 1 : 10, you would be inclusive on the left, but not inclusive on the right. Okay, this is different. Now we're inclusive on both sides. You could possibly be A or B. So that's kind of confusing, right? But it is what it is, you know. Just have to get used to it. So let me just show you this in practice over here. I have that command. So import random here has to come first. That library has been plugged into so that in line 9, Python knows what you are talking about when you write the word random there. So I'm just going to choose a random number between 1 and 10. Whoop. Sorry, I had something previously running. Let me flush it out. Okay, so choosing a random number between 1 and 10, it gave me a 3. And if I run it again, it gives me an 8. If I run it again, it gives me a 7, and so on, right? Every single time I click play, it's choosing at random a number between 1 and 10. So so far it's giving me 2 3s and an 8 and a 7. If you keep doing this, presumably you will eventually reach all numbers between 1 and 10. But they could be 1, could be 10. Let's see if I can eventually get a 10 out of it, or a 1. It's not, okay, there are a couple 1s, right? So it could be a 1. And I'm not going to keep going until I get a 10, but anyway, you can get either 1 or 10 or anything in between. It's an inclusive command. Okay, so once you know how to generate random numbers, an obvious application of that is to roll dice. So here's a command that will roll a standard 6-sided fair die. Okay, so all the sides are as likely to show up as any other. You can just choose a random number between 1 and 6. Okay, so if you had dice with more sides, say you had a 20-sided die, you could just put a 20 right there instead of the 6. What this code can't do, at least not without some modification, so maybe you could think about it, and maybe later in the course we can talk about it. How do you handle dice that aren't fair? Like, what if a 1 is more likely than a 2 or something because the die has been weighted? This code won't handle that, but anyway, we can think about that later if you would like. This command here simulates rolling a single die. What if, as in many casino games, you want to roll a couple of dice and then add them up to get a sum, You can do that using these 3 lines here if you would like. So roll die 1, roll die 2, and then record the result. So I have that here. Let me get rid of this. So as always, I would suggest that you follow along with your own compiler. I would suggest you type this code yourself and monkey around with it and just play around with it. So if you get something different when you change these numbers, say, right, just sort of play around with it. Anyway, so I rolled the first die, I rolled the second die, I recorded their sum, I printed the sum, and I got a 9. So these individual die may have been like, what, a 5 and a 4, or maybe a 6 and a 3, who knows, right? There's a 6 as a sum, a 4 as a sum, 7 as a sum, and so on. Okay, so here's how you can roll a couple of dice and record their sum. Okay, our next example is writing code that simulates rolling 5 dice and creates a list of those 5 rolls. So how might that look? Well, you can create an empty list where your rolls will go, and then just set up a for loop that's going to run 5 times. So again, the nice thing about for loops is you can control in their actual syntax how many times they run. So when you write for k in range 5, k takes on the values 0 through 4, so you know this is going to run 5 times. Every time it runs, what does it do? It rolls a die, a number between 1 and 6 is randomly chosen, then that number is thrown into this list. It's just appended to the end of the list. So, you know, if you want to roll 60 dice or whatever, and just record the results in a list, you can put a 60 right there. And now you've rolled 60 dice, and you have a record of those rolls because they're in a list. Okay, our next example is a gambling game that is not popular now because it's kind of boring, I guess, but it used to be fairly popular. You used to be able to play this like on the streets of London. It's a game called High-Low. So again, you won't be able to play this at like Isle of Capri if you go down there tonight, but this used to be fairly popular. So here are the rules. You bet either high or low, so there's only 2 options for you. Then you roll a couple of standard 6-sided dice and record the sum. The roll is high if that roll is at least an 8. The roll is low if it's a 6 or less. You win the game if your bet matches what was rolled. So if you bet high and the roll is high, say the roll is a 10 or something, then you win. But if you bet high and the roll is a 4, you lose. And notice that if the dice roll a 7, that's just an automatic loss for you. You're actually not allowed to bet on 7. That's an automatic win for the house. So let's write a program that lets the user play this game as many times as they want. So before showing you the code, let me just point out what I've pointed out, I think, several times to you individually and also in previous videos. Once you start writing more sophisticated programs, and I think this counts as one, you do not want to just jump straight into writing code. You want to sort of logically think out precisely how the code is going to go, and the more precise you can be, the better. Okay, so the more precise of a schematic you have like this is like an English roadmap of the program, the more precise you can be here, the easier it will be to take this English and translate it to Python. So here's just sort of a roadmap of how this program will go. We're going to have to get the bet from the user, of course, right? That seems like the first thing to do. We'll then roll the 2 dice and get their sum. We should then see if the sum is high or low, and of course, check if that matches what the user said. And if there's a match, we should say they won. If there's not a match, we should say they lost. And then we can ask them if they want to play again, and then just loop back up and do all that over again. Okay, so let me run over to the compiler and show you the game. Let me get rid of all this. So I have this code already typed. Again, not to belabor the point, but if I were you, I would say pause the video and type this, or play around with it, or maybe try to create your own, you know? So before I walk through this, I should say this exact sequence of code here is not the only way you can implement this game. It's just the way I implemented it. You could maybe think about other ways of doing it. But anyway, here's the game of high-low, letting the user play it. So first, we get their bet from them. Do you want to bet high or low? Then we roll the 2 dice and get their sum, just like before. We then show the user what the sum was and print it to them, you know. And by the way, if you haven't seen this command before, this comma end equals space, recall that the way print commands work is that they default to starting a new line when they are done. So if you don't want that, if you don't want a new line, you can just put a comma and then end it however you want. I just end it with a space so that when I print the sum here, that just comes on the same line. So these two print commands will actually occur on the same line in the output box because I've ended this first one with a space, not a new line. Okay, anyway, if the sum is low, right, that's what this is saying, then when you're inside there, if the bet is also low, you can tell them they won, otherwise tell them they lost. Otherwise, what if the roll is high? Well, if they bet high, then they won, otherwise they lost. And notice there's this catch-all else at the bottom. What is this doing here? Well, we've already covered 6 or less. We've already covered 8 or more. So what's left is that roll of a 7. So 7s go down here as automatic losses. Okay, so let's just play this game here and make sure it's working properly. I'm going to bet high, see how I do. I rolled low, so I lost. Okay, so that at least worked. Let's see if I can get a win. I'm going to bet high. Oh, I lost again. I'm going to bet high. I'm not doing very well with high, but eventually it's got to work out, right? Man, I keep rolling 6s. How is that possible? I'm going to bet low. As soon as I bet low, it switches to high, so I keep losing. All right, finally I didn't roll a 6. I rolled an 8. Okay, I just want to see if I can ever win. Man, I'm terrible at this game. Okay, finally. I bet low. The sum was 5. That's low, so I won. You know, my bet matched the roll. So that seems to be working fine. Okay, so before we leave this example, let me just point out, we were supposed to ask the user if they want to play again, and if they do want to play again, I should let them just do this entire thing over, just let them play again. Okay, so if you ever just have a chunk of code already in your compiler, and you want to just let the user decide if they want to do it over again, or just in general, if you ever just have a chunk of code, and you want to now put it inside of a loop, so that this chunk of code can repeat if you want it to, in this case, the easiest way to do that is just to create a loop like this. So this loop, the user decides if they are going to repeat or not. So I'm just going to ask them in the end, do you want to go again, yes or no? And if they say yes, I want this code to repeat. So by opening this program, they sort of implicitly said yes to begin with. So I'm just going to initially assign a yes to this response. Oops, I don't need a double equals there, sorry. Initially, I'm going to assign yes to response so that this loop runs, right? Presumably they want to play. And now all of this, the game itself has to be in the loop, which means it has to be indented. So I'm just going to hit my tab key right now and watch. It all just shifts over. So everything now is at the right spacing indentation level. So all of this, that's the game, right? When the game is over, what do you want to do? You want to then ask the user, like, hey man, do you want to play again? Let me just ask them that. Oops, I don't know why I keep doing double equals. Right, you only use double equals inside of a Boolean statement, inside of an if or a while or something. Anyway, so play again. And if they say yes, then when the program jumps back up here to check if this condition is still true, if they say yes, that condition is still true. So this thing will keep going. Okay, so let's just watch that go. I'm going to bet high. Oh, I lost. And it asked me, do you want to play again? So I'm going to say yes. For why, right? And it just repeats. You know, I'll bet low this time. I lost. Okay, well, I'll play again. Why not, right? High. I lost. And so on, right? Like the game. This is the game, right? Just keeps repeating over and over again as long as right here, as long as I keep giving it a lowercase y. So notice, right, I mean, the program's literal. So if I do this, suppose I bet high at first, play again. If I type yes, notice it stops the program, okay? Because the program doesn't know that when I type yes, what I actually meant was a lowercase y. So anyway, you have to be a little careful with this, but it does work as long as you know that what keeps things running is a lowercase y. So anyway, that's high-low. A couple more quick examples and then we're done. So here's a task that might be of use to you. Suppose you have a list going and you want to choose some element of it at random. Well, doing that basically boils down to choosing a position inside of the list at random. So the positions inside of a list run from 0 all the way up to the length minus 1. Right? So if your length is 10, then you could go from position 0 to position 9. So you could just choose a position at random and then access it like this. Put that random position inside of the list like that. So let me just show you that real quick and get rid of all this. Again, if I were you, hopefully you have this typed somewhere now. So here I've created a list called My List. Suppose I wanted to choose one of these items at random. Well, then I could just choose a position between 0 and, in this case, what? 3, 6. This has length 8, so the 13 is in position 7. So choose a position at random between 0 and 7, and then just access the element at that position by putting that position in square brackets. So if I run this, it outputs a 6. So presumably it chose at random either that position or that position. There are multiple 6s, right? So I don't know unless I tell it to show me, right, how it got that. There's another 6. It chose a 7. So either it chose a position 2 at random or a position 5 at random. Anyway, that's how you can choose at random an element of a list. Let's see if I ever get that 13, right? So I got the 13. So it actually chose the position 7 at random. So anyway, if you have a list going and you want to just randomly pluck an item out of it, you can do it like that. You have to randomly choose a position first and then just pluck out the item at that position. Finally, in the end here, right, we've talked about rolling dice. Flipping a coin is like rolling a die, right? I mean, a coin is basically a two-sided die. So if you want to simulate flipping a coin, you could do something like this. Choose at random between 1 and 2, right? There are only two options, right? A 1 or a 2. And then you could decide that a 1 means a heads and a 2 means a tails. You could flip that. It doesn't matter, you know. But anyway, flipping a coin just means choosing at random between two numbers. So choosing between 1 and 2 can flip a coin for you. Okay, so hopefully this video was clear in its introduction of randomness and how you can merge randomness with things like loops and if statements to create some pretty nice little programs, right? This little high-low thing is pretty cute once you implement it. Okay, that's all.